Algebra 1a, 1.5, Part 1, Mean Absolute Deviation. Short, you can call it MAD. Find the MAD, okay? What the mean absolute deviation is going to do is it's going to give us a measure that comes up with the average distance that each data is to the mean. So this will kind of tell us how far our data is spread out. So our first step is to find the mean. Okay, add up all your numbers, divide by the total amount of numbers. Next step, find the distances of each data value to the mean. So our first data value was 2, so we take 7 minus 2 is 5. Okay, 7 minus 4 is 3. If there's numbers that are above 7, 8 minus 7 is 1. So you won't get any negative numbers when you do that. Okay, and then the last thing we're going to do is find the average of those new numbers. That becomes your mean absolute deviation. So let's try one. All right, find the mean absolute deviation of sets A, B, and C. So first thing we need to do is find the mean. So to find the mean, we're going to add up all those numbers. 2 plus 4 plus 6 plus 15 plus 18. So go ahead and do that quick and then divide by 5. So I get 45 divided by 5, which becomes 9. So that's my mean. That second step, if you can remember up here, we're going to find the distances of each data value to the mean. So how far is each data point to the mean? So I'll just say distances for short there. So what we need to do is we need to take that 9 and then subtract each of these numbers. So if I do 9 minus 2, then we're going to get 7. Okay? Then do it again with another value. 9 minus 4 would be 5. 9 minus 6 is 3. If the number is bigger, we're going to go backwards. 15 minus 9 is 6. 18 minus 9 is 9. So now finally we're on to that step 3. Okay, find the average of these distances. So what are the average of these distances? So I'm going to call this the MAD, the mean average deviation. Okay, so we're going to add those numbers up. 7 plus 5 plus 3 plus 6 plus 9 and divide it by 5. Okay, so if we add up all those numbers, $30 divided by 5, which ends up being 6. So our average was 9 and our mean absolute deviation was 6. So that's how far our data set was apart. Okay, so why don't you pause it and try B and C. All right, so for data set B, the average, the mean became 9. And so same average as in the first set, but this time our MAD, our mean absolute deviation, was only 2, because if you look at these points, the numbers are a lot closer together than they were in set A. Set A, they were a lot more spread out. Okay, and then data set C, our numbers are even closer together. They're the same number every single time. So our average was 9 and our mean absolute deviation was 0 because the numbers didn't deviate at all. Okay? All right. So interpreting, how do outliers affect the mean absolute deviation? The closer the mean absolute deviation is to 0, the less variation there is in the data. And then those outliers, those numbers that were way far apart, are going to raise that absolute deviation. They're going to make the numbers more spread out. Let's try a couple more. Find the mean absolute deviation for each set. All right, we'll do the first one together and then you can try the second one. So that first step was to find the average of your numbers. So we're going to add those up. and divide by 5. So go ahead and calculate that. So 430 divided by 5 ends up being 86. So 86 is our average. So now we need to find how far are these points away. So this is that distance. How far are our points away from the average? So we take the first one, 90 minus 86 is 4. The next one, 81 minus 86, or in this case 86 minus 81 is 5. 86 minus 85 would be 1. 92 minus 86, which is 6. 86 minus 82, which is 4. So now you're finding that mean absolute deviation. So we're going to take all those numbers, 4 plus 5 plus 1 plus 6 plus 4. Add them up and divide by the amount of numbers, which again is 5. Okay, so we end up getting 20 divided by 5, which equals 4. So our mean absolute deviation is 4. So that's how far the numbers are spread apart. All right, you guys try number 2, and then go ahead and pause the video. All right, check your last example there. The mean absolute deviation in this case was 7. Okay, the average was 12. And then notice that outlier, that 17, that's what really pushed up our mean absolute deviation. All right, you can get started on the homework.